A sequence of geological events has unfolded in recent times, compelling seismologists worldwide to scrutinize their monitoring equipment with growing concern. These developments are not occurring in remote Pacific regions or isolated mountain territories. Instead, they're manifesting within the core of our civilized world. Spain experienced an unexpected seismic event that caught experts off guard, followed 7 days later on July 20th by earth tremors of such intensity on far-off Kamchatka that dormant volcanic systems began displaying renewed activity. These two occurrences, though separated by vast distances spanning thousands of kilometers, share a disturbing commonality. Tectonic formations appear to be operating as though an acceleration mechanism has been activated, with the most concerning aspect being not chaotic movement, but a discernible sequence suggesting the commencement of a fresh era of global geological disruptions. What drives scientific consensus regarding elevated tsunami probabilities across Mediterranean waters? How do Spanish tremors measuring magnitude 5 connect with Kamchatka's magnitude 7 seismic events? Most critically, do these phenomena signal something far more catastrophic approaching? Dawn broke on July 14, 2025, as inhabitants of a picturesque European coastal community were roused not by avian melodies or oceanic sounds, but by their dwellings beginning to oscillate like fragile card structures. At precisely 7:13 local time, the ground beneath Spain's southern coastline convulsed with 5.2 magnitude force. The intensity proved sufficient to set residential lighting fixtures swinging, while underground transit passengers found ceiling materials cascading onto their unsuspecting heads. The seismic epicenter positioned itself merely 55 kilometers from Almería, a city housing nearly 200,000 inhabitants. The hypocenter rested at an alarmingly shallow 2-kilometer depth, creating a singular consequence. Underground energy transmission occurred with minimal dissipation to surface levels, triggering tremors across more than 50 urban centers spanning from Granada to Alicante. 7 days prior to this main event, the identical region had already recorded tremulous activity registering 2.5, followed by 3.2 magnitude readings. The Earth appeared to be conducting preliminary exercises before delivering its principal assault. The reality remains that the Iberian Peninsula occupies one of Earth's most geologically stressed locations, positioned at the convergence point of two massive tectonic formations. The African continental plate applies relentless pressure against its Eurasian counterpart at rates measuring several centimeters annually, generating enormous crustal tension. Spain itself rests upon what geologists term the Iberian microplate, essentially compressed between these geological giants. The Azores-Gibraltar-Tunisia fracture system traverses directly through Spain's southern territories, transforming this region into a perpetual seismic hazard zone. March 1954 witnessed a devastating 7.9 magnitude earthquake that devastated southern Spain, inflicting substantial destruction across Malaga, Madrid, Granada, and Cadiz. The year 2011 brought genuine terror to Lorca City through a sequence of earthquakes reaching 5.5 magnitude levels. Italian territories similarly cannot escape this seismic narrative. Naples endured its most powerful earthquake in 4 decades, measuring 4.6 magnitude. However, if Spain and Italy appear geographically distant for earthquake concerns, prepare for startling revelations. Central Europe itself, specifically Austria's Tyrol region, experienced a 4.5 magnitude earthquake that awakened residents through thunderous ground noise. NASA research combined with European scientific investigations has identified an active seismic corridor originating in Germany's Eifel region and encompassing Belgium, Netherlands, France, and Luxembourg. Geological processes are unmistakably developing within northwestern Europe's heartland, as researchers have detected dome-like crustal movements indicating ascending molten rock approaching surface levels. Returning focus to Spain, comprehending why this magnificent nation transforms into seismically hazardous territory requires examining deep subterranean conditions where genuine geological transformation unfolds. Beneath Mediterranean waters, an entire tectonic plate has undergone complete inversion. Chinese University of Science and Technology researchers determined that the Alboran plate, representing crustal segments beneath waters separating Spain and Morocco, previously descended rapidly beneath Earth's mantle before completely inverting. Oceanic waters formerly covering this plate's surface now rest beneath it, establishing low-velocity layers through which seismic energy passes with jelly-like characteristics. This inverted underground configuration explains Spanish seismology's most peculiar characteristic, profound earthquake origins. 2010 witnessed a 6.3 magnitude tremor beneath Granada occurring at 616 kilometer depths. This represents double the typical earthquake focal depths and 10 times deeper than recent Almería area activity. Such profound depths should theoretically dissipate energy, yet surface transmission occurred virtually undiminished. While contemporary 5-magnitude earthquakes present serious contemporary threats, historical records preserve far more devastating occurrences. November 1st, 1755, transformed All Saints' Day into a date permanently altering European historical trajectory. At 9:40 a.m., as Lisbon's religious structures overflowed with congregants, earth tremors reached 8.5 magnitude intensity. The most catastrophic developments commenced 30 minutes following the primary shock. Tsunami waves measuring 16 meters in height devastated the already damaged Lisbon. Minutes sufficed for these waves to eliminate one of Europe's most prosperous urban centers. Lisbon alone suffered 60,000 fatalities, with neighboring communities experiencing additional 6,000 to 8,000 deaths. Contemporary seismologists caution against dismissing repetition possibilities. Alboran sea fault systems could produce tsunamis reaching vacation destinations within minutes. Spanish construction regulations have undergone strengthening following each disaster. Since 2007, adobe brick construction and similar fragile materials have been prohibited. These materials caused numerous Lorca casualties during 2011 events. However, centuries-old architectural structures remain exceptionally susceptible. Granada and Seville's historic districts still contain buildings vulnerable to magnitude 4 tremor collapse. Positive developments exist nonetheless. Iberian Peninsula seismic activity levels remain comparatively low versus Turkish or Japanese standards. African plate pressure against European formations proceeds at mere millimeter-per-year rates, representing tenfold slower movement than Turkish plate dynamics. Consequently, catastrophic Spanish earthquakes occur once per century rather than every decade. Nevertheless, Spanish geological experts express alarm. Since 1944's last genuinely destructive earthquake, 7 decades have elapsed. Statistical patterns suggest centennial cycles. This indicates the subsequent major seismic event could manifest within the coming decade. As European seismologists examined continental underground processes, the planet's opposite hemisphere witnessed dangerous developments of entirely different proportions. July 20th brought Kamchatka Peninsula a seismic sequence that disturbed not merely terrestrial foundations, but thousands of human spirits. Initial catastrophic indicators emerged at 18:02 local time, a 5.3 magnitude tremor occurring 140 kilometers from Petropavlovsk-Kamchatsky. This represented merely a precursor, termed a foreshock by seismological professionals. 26 minutes later arrived a more substantial 6.7 magnitude impact, sufficient intensity to generate public panic. Following an additional 20 minutes at 1848, the principal occurrence materialized, a 7.6 magnitude earthquake transforming ordinary evening hours into nightmarish conditions. The earthquake's focal point resided approximately 50 kilometers below surface, adequate depth for partial energy dissipation during upward travel, yet insufficient to prevent peninsular residents from experiencing significant effects. Petropavlovsk-Kamchatsky registered 7-point intensity levels. Serious measurements capable of structural damage and inducing fainting-level fear among populations. Nature's performance remained incomplete. The primary shock initiated extensive aftershock sequences. Earth movements resembled fevered patient convulsions, denying human populations momentary relief. Consequences became apparent as damage reports accumulated. Psychological impacts proved enormous. At this juncture, another formidable natural force emerged: oceanic systems. Such magnitude earthquakes possess tsunami-generating capabilities, destructive wave formations that convert peaceful sea surfaces into mass destruction instruments. Emergency ministry officials formally declared tsunami threats for Kamchatka and northern Kuril coastal areas. Warning sirens activated along entire coastlines, with immediate coastal zone evacuation and elevated terrain relocation recommendations for all residents. Fortunately, oceanic forces showed mercy during this occurrence. Anticipated wave arrival times passed without tsunami materialization. Possibly seafloor topographical characteristics or specific earthquake mechanisms prevented dangerous wave formation. Meanwhile, subterranean drama continued as aftershock sequences proceeded consecutively, exceeding 400 registrations within initial 48-hour periods. 20-minute intervals brought renewed earth trembling, preventing population relaxation. Subsequently, completely unexpected developments occurred. Avachinsky volcano, maintaining daytime tranquility, suddenly responded to seismic activity. Immediately following tremor sequences, it produced steam gas emissions reaching 200 meters above crater levels. Institute of Volcanology and Seismology specialists immediately recognized this correlation as non-coincidental. Volcanic responses to seismic events provided clear demonstrations of interconnected geological process relationships. Avachinsky represents one of Petropavlovsk-Kamchatsky's nearest volcanic systems, positioned merely 25 kilometers from urban areas. Its geometrically perfect cone, measuring 2,741 meters in elevation, remains visible from virtually every Kamchatka capital location. When such geological giants exhibit renewed activity, concern represents natural human responses. Steam gas emissions don't constitute eruptions, but signal magmatic system reactivation. Historical evidence confirms that powerful earthquakes can indeed trigger volcanic eruptions. Classical examples include Indonesia's Galunggung volcano eruption during 1822, preceded by intense subterranean tremor sequences, or temporally closer instances. Iceland's volcano with complex pronunciation that paralyzed European aviation systems for multiple weeks during 2010. Returning to July 20th events, while volcanologists analyzed Avachinsky behavioral patterns, underground aftershock processes continued at unprecedented scales. Aftershocks don't represent simple residual oscillations as commonly perceived. These constitute complex Earth's crust stress state restructuring processes following primary rupture events. Initial 2-day periods following main events witnessed seismographic registration of over 400 varied magnitude aftershocks. July 21st morning brought another 5.8 magnitude earthquake 150 kilometers from Petropavlovsk-Kamchatsky, with focal depths measuring 58.4 kilometers. Many residents reached breaking points. Nervous systems could no longer tolerate constant tension. Leading seismic monitoring laboratory scientist Odintsov explains such earthquakes represent uncommon, yet not unique phenomena. Comparable seismic events affect Kamchatka approximately once per decade. Previous analogous powerful earthquakes occurred during 1971, though epicenters positioned much closer to populated regions, resulting in more severe consequences. Notably, July 20's powerful earthquake experienced foreshock precedents, weaker tremors seemingly preparing conditions for main events. Initially, less than 1 hour before primary strikes, magnitude 5 earthquakes occurred, with additional strong tremors 20 minutes prior. Therein lies the danger. Even strong earthquakes might represent foreshocks of more powerful events. Fortunately, aftershock behavioral analysis confirmed the magnitude 7 earthquake represented the main event rather than precursor to stronger strikes. However, seismologists don't eliminate possibilities of additional noticeable tremors during upcoming days and weeks. Earthquake mechanisms completely corresponded to regional geomechanical conditions. This represented typical interplate earthquake activity within subduction zones, precisely the event types making Kamchatka among Earth's most seismically active locations. Understanding Kamchatka's transformation into one of the planet's most seismically active regions requires geological perspective examination of this territory. This peninsula occupies a unique convergence point for 3 tectonic plates: Pacific, Okhotsk, and North American formations. Primary roles involve subduction processes, heavy oceanic Pacific plate descent beneath lighter continental Okhotsk formations. Process velocities measure approximately 8 centimeters annually, representing incredibly rapid geological timeframes. Million-year periods witness 80-kilometer plate descents, dragging seawater and sedimentary materials into mantle depths. These waters perform crucial roles in Kamchatka's seismic processes. At 100 to 200 kilometer depths, under enormous pressures and temperatures approaching 1000 degrees Celsius, water begins mineral separation, reducing surrounding rock melting temperatures. Thus magma originates. Molten rock nourishing the peninsula's numerous volcanic systems. Water influences extend beyond volcanic activity. Oceanic plate hydrated minerals create reduced strength Earth's crust zones where ruptures and corresponding earthquakes occur more readily. This explains Kamchatka's regular surface and deep earthquake experiences extending to 700 kilometers below surface levels. Kamchatka earthquake statistics prove simultaneously impressive and alarming. Past century records exceed 50 earthquakes measuring above magnitude 7. This averages serious seismic strikes once every 2 years for the peninsula. July 20, 2025, scaled events with 7.6 magnitude occur approximately once per decade. However, Kamchatka's most terrifying historical event remains the 1952 North Kuril tsunami. November 5th at 4:58 a.m. local time witnessed a magnitude 9.0 earthquake off southern Kamchatka shores, among humanity's strongest recorded events. 15 to 20 minutes post-earthquake, initial 5 to 6 meter tsunami waves approached Kuril Island coastlines. These didn't produce major destruction, prompting many residents to observe unusual phenomena. This represented reconnaissance only. 20 minutes later, second waves measuring 10 to 12 meters appeared, eliminating most structures, while third waves completed destruction, 18 to 20 meter heights, representing water walls equivalent to 7-story buildings. Official data declassified 40 years later cited 2,336 fatalities, though Kamchatka historians and journalists reference 10 to 14,000 casualty figures. True tragedy scales remained concealed within Soviet archives for decades. Complete settlements vanished from Earth's surface, with survivors describing oceanic transformation into raging cauldrons consuming everything within their paths. 1952 events marked turning points in Kamchatka seismological history. Kamchatka prepares additional human surprises. The peninsula represents among Earth's most volcanically active regions. Over 300 volcanoes exist here, with 68 classified as active systems. Many possess planetary-scale eruption capabilities that could alter entire Earth's climatic conditions. If you found this interesting, please like this video and subscribe to our channel.